Hello. In this video, I'm going to demonstrate to you how to construct some common charts using three datasets. So it'll be a hands-on illustration of the charting capabilities of Tableau for three datasets. So let's take a look at our datasets first. First one we have is a dataset of fast food data. This dataset has three variables measuring health concern on a 1 to 7 scale gathered through a survey. We have three restaurant rating measures also gathered on a 1 to 7 scale. Gender has 2 levels, male and female. Location has 4 levels, Manhattan, Brooklyn, Queens, New Jersey. And there are 5 levels for age. We're going to first examine health concern by gender and location, then compare rating of the 3 restaurants by location in a single chart. Okay. Let me go ahead into Tableau now and load up the data set. Here's my Tableau view. And the file I'm going to be pulling into Tableau is a file called fastfood.csv. Since this is a CSV file, CSV is short for comma separated values. And those are basically text files with commas separating consecutive columns. So I'll click on text file from the left menu and look for this file called fastfoodtableau.csv. Now that I have it selected, I'll go ahead and click open to bring that into my Tableau view. So fastfood Tableau, when it comes in, looks as follows. You can see on the on top the file being depicted, and then we can also see a variable description here below, and there's also the raw data we can look at. The bird's eye view of our data tells us we have 13 fields with 2,000 rows, including variables health 1, 2, 3, McDonald's, Chipotle, Shake Shack, gender, age, location, so on, and rank. Now, let's take a look at some of our variables. ID has been identified here as a number, a whole number. That seems fair, although it's not, shouldn't be mistaken as a numeric variable, because that would be nonsensical. Health 1, 2, 3 have been parsed as numbers, which makes sense. The survey scales. Similarly, McDonald's, Chipotle, Shake Shack are also scale variables, or sorry, numeric variables. Gender has been absorbed as a character or string variable. Same with age, and lastly, location. Let's go over to sheet 1 and start building our chart. Our first goal here is to compare health concern by gender and location. So we have here 3 health variables, health 1, 2, and 3. We're going to try and compare these using first gender and then location, and then both them. You can move health 1 over to, let's say, the rows shelf, see what happens. We get a vertical bar. I'll move gender over to columns to see what that's going to do for me. So we get now a vertical bar chart. Generally speaking, horizontal bar charts are more desirable, so I'm going to swap rows and columns so it looks like a horizontal bar chart. Next, I'll go in and convert health 1 to be a average measure. So you can see out here, for example, on the first health 1 metric, females score higher, indicating greater health concern than males for that first health variable. We can also break this data down by location. So let's bring location into our view. Now you can see sort of like the breakdown of male, female, and also by location. So you can examine the comparison across Brooklyn, Manhattan, New Jersey, Queens, for both males and females. What stands out here is Brooklyn males have a really low concern for health compared to everybody else. That's interesting. Okay. Now, since our data is gathered in a 1 to 5, 1 to 7 scale, it might make sense to change our scale range to a fixed range of 1 to 7 to appropriately show the range of our data. So we have it. Since people can only mark numbers 1 through 7, it might make sense for tick marks to be whole numbers as well. Okay. So here we have it. We see a contrast of males and females, and broken down by location to understand their health concern. If you'd like to, you could also drag in health onto a label, so you get the labels at the end of the bars. You can, of course, also format the labels to not have decimal places or have fewer decimal places. Let me go with here a 1 decimal place precision. There we have it. Now, I'm not a big fan of using color unless you need to. If you really think your color is relevant out here, you could potentially bring gender onto color or location onto color, but you risk making this graph too colorful. You don't want it to go there. But let's see how this would make sense in some context. If you're interested in contrasting males to females across the 4 locations, you could drag gender onto color and then specify gender stereotypical colors. Of course, you want to be careful about picking stereotypical colors because people might be offended at times if you're when you assign gender stereotypes to people by colors. So just be aware of that. All right, so here we have it. We have data here by location and gender. You can see that we can again compare these all in one view. Okay, what I'm going to do next is I'm going to replace health 1. Instead of using health 1, I'm going to use a metric that reflects the average of the 3 health variables. So you can create a new variable in Tableau using the create function. So I'm going to say create calculated field. Here I'll say I'm going to call this health. And I'm going to say health is pretty much health 1 plus health 2 plus health 3. Oops, I missed that part. Divided by 3, and that's basically going to be the average of those 3 scales. Right? And now I can replace average health with health to get a sense of, again, how data is going to look for across the different, so again, use the average of health and also put health onto the label. So now we have a measure that's going to represent the average for those 3 health concern items that were in our survey. And I'll fix our scale again to make sure it goes from 1 to 7 and has tick marks every 1 unit. Oops. So I lost our scale. Okay. Tick marks are going to be fixed 0. Okay, here we go. There we have it. Now you can see sort of like a contrast here of males to females across different locations. You can tell in Brooklyn, especially, the contrast is most striking. Okay, now that you have this thing, what you might want to think about is, can you maybe represent the same information in, say, a heat map? Okay, so let's take a look at how that can be done. In our first graph, we just compared, compare health by gender and location. Now do the same thing. We'll just do this by using a different chart. Okay, potentially doing this with a table or a heat map, better still. So I'll name this sheet the same as before, because our goal is to do the same thing as we did before. So here again, I'll take gender and location, put them up here, maybe have gender, location, and rows and columns. Looks better that way. And I can drag health over to text. Change that to average and format that so that it does not have so many decimal places. And lastly, I'll put health onto color so we can maybe get a heat map out of this. I'll set the mark to square so the backgrounds are colored. And now we have a heat map showing us. We'll change the color palette to be, let's go with one that's a converging palette. We can go with here green gold, because green seems to reflect. It depends on what we want to convey to people now. We want to convey that being unhealthy is alarming or being healthy is a good thing, right? So let me assume we're being more positive out here. And so we're going to say that being green or being healthy is a good thing. So higher numbers, more green, lower numbers, more yellow. And I think it would look better if we swap the axes out here. So here we have it. The heat map representing the two genders. It doesn't make sense to have different palettes, different scales for different genders here. So I'm not going to bother with setting out a separate legend out here as we could potentially do. Okay, so that's one way you can, another way you can compare health by gender and location. Moving along, we're going to go on now to see how we can contrast the 3 restaurants rating in a single chart. So bear in mind, anytime you've got chart 2, anytime you've got multiple measures like these 3, you cannot use them as such in a chart. Location first column. So location is going to go over to rows, and then we'll see if we drag over Chipotle here, and then McDonald's and so on, we're going to get 3 different graphs. We want one chart. So rather than using the raw variables, we're going to use measure names and measure variables. This will enable us to construct just a single graph rather than having these multiple graphs. I'll select here McDonald's, Chipotle, McDonald's, and Shake Shack. And we're going to examine this bar chart now for average scores or average ratings. As before, I'm going to set the scale to be 1 to 7 because the data was gathered in that scale. And we'll set tick marks to be fixed with the 1 unit interval. And there you have it. We can also drag measure values onto labels, so we get the labels on here. Should somebody want more precision about any given restaurant's rating. I've set them to be 1 decimal precision, but you could always change that to 2 decimal precision if you see fit. Finally, let's sort this data based on rating of the restaurant. So I'm going to go into location, sort measure values here. I'm sorry, sort locations, I guess. In descending order of their rating. So it would make sense actually. I'm going to go back to what we had before rather than going down this route. So I'm going to just reset this. The clear usually resets your graph. So having alphabetical order for locations isn't a bad idea, but for our measures, it might make sense to sort them in terms of measure values. So let me see if I can do that. It actually won't give me an option for that. So that does make sense. I'll leave it the way it is then. Okay. Great. So we have a second graph here. Now, the key thing to notice here is we've got multiple measures and a single dimension in our graph out here. Right. Our 3 measures are Chipotle, McDonald's, and Shake Shack, and our dimension is location. All right, let's move on to another example then. Let's label this before we move on. So compare ratings. As noted before, we could, of course, decide to go with different colors for different bars, but I think it's better to just keep them vanilla plain here. Let's move on to looking at another example now. The second example or exercise involves looking at album sales data. Now, typically, if you've got multiple continuous variables, one natural thing you'd think about doing is looking at relationships amongst those variables. One way to do that is to examine a scatter plot. So we'll here examine the relationship between adverts and sales using a scatter plot, and we'll kind of include a regression or trend line in that data. So here we are, and we're going to scatter plot. Now, we don't have the data yet, so when I've gone ahead and prepared myself to create a scatter plot, let's go and get the data. To get the data, we got to go back to the start page by clicking on the Tableau icon, and then look for the data. The album dataset is an SPSS file, which fits in the category of statistical file. So clicking on that will take me to and show me album sales. We'll pull that into Tableau and quickly review our data. We have data on adverts, sales, airplay, attractiveness. All of them are ID variables, which is good. All of them are, sorry, measures. Sorry, I got distracted there. All of them are measures. Now, usually, in most data sets, you have a variable called an identifier variable. In our data set, we don't have it, unfortunately. It's going to present a small problem, but no worries, we'll get around that. So we have your adverts going in rows, and we'll put sales in columns. Now, as noted before, you're going to get one dot because by default, Tableau will aggregate a measure into sum or average or some such aggregation. What we need to now do is disaggregate this. Usually, you would drag the identifier variable onto detail to disaggregate the variable. However, in this case, we don't have an identifier, an ID variable, or a unique identifier for every observation. So we got to improvise. We can go to analysis here and say under analysis to not aggregate measures. So you uncheck this box, you'll see dots all over your data. We're going to make these dots to be solid circles. And next, examine our data to think about what is our expectation. We're expecting adverts to influence sales. So going with the norm, we're going to swap rows and columns so that our dependent variable is on the y-axis. Here's a scatter plot of our data. Lastly, we want to fit a line to kind of see what the trend of our data is. It does look like it's bottom left to top right, and therefore linear trend. So let's go to analytics and drag in a trend line onto our graph. There we have it. Our regression line shows us we have an R-squared of 0.33. Look for more detail out here. We also know what the equation is of our line, and that the effect of adverbs is statistically significant. Now, if you would like, we could always create another graph in the same sheet. Probably going to make it a bit crowded, but we could do it. So let's see how that would look. What if we dragged in adverts next to columns? We get a second graph that looks like this. Okay, makes it look really busy. I don't recommend doing this. Maybe it's better to make a second separate scatter plot altogether to examine that relationship. Okay, but I'm sure you get the idea right now. We can always duplicate this sheet once you've formatted it suitably. Another color, and it's good enough. Duplicate this sheet, and now we can always replace adverts with airplay. Look at that relationship, and then note the relationship there, and then repeat that for a third variable. Our third variable, of course, is going to be the effect of attract on sales. So here we are. And you can notice a sort of strange graph because attract is a survey metric. The attractiveness of each single is measured on a 1 to 10 scale with discrete options. Hence, you see the sort of this banding of your data in the scatter plot. So all three represent or show us a decent R squared. The airplay is probably the weakest of the three predictors, and you kind of see here p-values indicating statistical significance. Okay, we're going to go on to our last example right now, which is going to be to examine changes over time. So many things change over time. One of them is the stock market. Let's examine some data for some prominent stocks over time. The data is a bit old. I should have pulled some fresh data. Nevertheless, we'll have some sort of a trend analysis of our stock data. Now, we want to open another data set. Please note that if you want to swap a data set right here, you can do that by clicking on the data set, fast food Tableau, for example, and back to all themselves. Okay. Now, let's click on the start icon to go right back to the start menu and then look for our stocks data. It's a CSV file, so I'm going to click on text file to look for stocks. Now, here's the stocks data. It contains a date field and fields for the 5 stocks we have data on. It turns out that Tableau has correctly mapped our variable as being date, and that's a good thing. When we click on a fresh sheet, we're going to look at a line graph. Now, what if maybe Tableau had not correctly parsed this variable and it was string? Well, you would simply change it to date and hope Tableau does it correctly. More often than not, Tableau will parse your variable correctly into the format it's meant to be in. And the benefit of it being parsed correctly is that you can then peel the layers of you can drill down on this variable. Let's examine, how about examine Facebook stock or Amazon stock? I'm so confused. They all look like good stocks to examine. And you can kind of see a nice upward trend in this graph. As it stands right now, our data is yearly and the categorical yearly. So what if I went to selected month? We're only going to find 12 data points, but we don't know what year it is for. Well, it's for the average of all the years. That wouldn't make much sense. Let's first make our stock price average. Okay, so we have the average stock price right now for different months to see if there's any seasonality in sense across the different years. Usually, you don't expect a stock like Amazon to have a seasonal pattern to it. So looking at an aggregation of months does not make sense. Instead, let's look at the stock of Amazon over the entire period by month. Here's the stock for Amazon over this entire period. We can, of course, drill down more and say, give it to me by day. You get that noisy pattern now of your stock showing up for Amazon. What we can do here now is I'll bring in a second stock here. Let's bring in Microsoft. Okay, that doesn't look very nice. So let's do this. Let's get Amazon out of here, put measure values up here, and measure names in here as well. So we can then examine all the stocks. Okay. There we have it. We get to see now, oops. we get to see our stocks, and we can see the trend over time to see how they've evolved, and which ones are kind of moving rapidly. If you overlay the measure names onto color, I'm sorry, before I even do that, let me just make sure the stock prices are average. And then let me drag measure names onto color and see what we get by way of comparing these different forms. So you can now see, in a sense, based on this trend, how these stocks have changed over time. Bear in mind that, of course, these different stocks, these prices are absolute values of stock prices or face value, and that might not be indicative of the gain somebody would get. Right? So, for instance, the starting point for Amazon's is 257, while that for Microsoft is much lower here in 2013. Okay. So here's how you could examine, for example, instance, many stocks in one single graph using measure names and measure values. Okay. Hopefully those 3 examples were enlightening enough, and you've got a sense of how to apply, create these different simple charts in Tableau for a given problem. Thank you.